Good morning, guys. Go ahead, let me know who's here. Looks like maybe one person. Morning, Hunter. How's it going, Hunter? You have a good weekend? That's good. Thanks for asking. Yeah, it was, normal, relaxed, but pretty good. Playing a lot of video games still. Watched a Michael Jordan documentary last night, which was really good. Got to talk to some people. It was fun. We're getting closer and closer to that date. What's today? We got the 20th today. So you guys have under a month now. So our AP test, well, all of your AP tests. I don't know. What's your soonest AP test, Hunter? Because I gotta imagine there's starting before the 12th too. Hey Rachel, how was your weekend? No idea when they are. Come on, Hunter. Rookie. I thought you'd have them circled on your calendar, Hunter, ready to go. Oh, hey Liberty. All right, cool. So three of you here. Pretty boring. How about you? Yeah, same here. Typical weekend. There's not too much. We had um we'll let you guys in on like a little secret, but I don't know if it's supposed to be. The teachers are making like a video, like collectively, so we're all making like a video of all the teachers for you guys. And so this weekend I got to like film myself, do some stuff. I think some of it's pretty funny, so we'll see. That kept me entertained for an afternoon. Just thinking of like creative different videos I could do. So that was good. I enjoyed that. I felt like a TikTok star. Liberty, how was your weekend? That was fine, pretty boring. Yeah, I think everyone's got that collective agreement. Trying to keep things interesting, but I did play with my friends. We played. I don't really know what all the games were called, but it was like that Jackbox TV thing. It had like all these different types of games that were pretty entertaining. So we played that this weekend. I recommend that if you guys haven't done that before or looked into that. It's a good way to spend a Saturday night, Friday night, or something. All right. That's a good one. Okay, so you've probably played, Rachel. I know one of them was Quiplash. That was really fun. There was one we had like draw stuff, which I was horrible at because I can't draw anything, so that didn't go over so well. I think I actually ended up winning though, because at the end of the day, the game doesn't really matter if you draw well. Like you have to draw stuff, but what's more important is that you have a funny caption to whatever people are drawing. So I won that, but the drawing part was not pretty. And there was like a trivia murder party, I think it was called, which was kind of interesting. Like these little puppets, and like if you get trivia stuff wrong, then you get killed basically. All right, so you guys can see on my screen the calendar's up. This is kind of the outline of the week. Keep it on the same type of schedule. So we got through all of the progress checks. So yay, congratulations. All of those are done. All obviously fantastic review material for the AP test. So this week what we'll be doing is these international practice exams. And these are just, I don't know if, well, no, they weren't the actual exams, but like from 2017, for instance, one we're doing today, it was a practice exam that was given out during that time. So it's good stuff, you know. It'll prepare you. It's good material, good types of questions, like kind of give you like a little hint on what you might see for the AP test. So these are gonna be really useful. We're gonna be doing those for the rest of the week. So we're gonna get all the way through the 2017 practice exam. 2018 we'll get through the first portion, and then we'll finish that up next week. For the 2017 one, we're skipping number 1. So in a second here, when we get started, we are going to skip number 1 because that's from Unit 9. And Unit 9, like I've said before, we're not doing. The AP test isn't doing, so I didn't want to spend time on it. We're just going to move on to some of the other ones. One thing I wanted to say before you guys get started is AP released this, they're like practice FRQ questions, I guess. Like stuff that I've been giving you, except these ones aren't assigned. Like I don't assign them to you, they're automatically assigned. So from my understanding, maybe you guys will be able to fill me in, because I think I saw maybe someone in this class like at least looked at them. Whether or not anyone did any of them, I don't know, but I think people like, looked at them maybe. And I'm not really sure because from the teacher's perspective, I can't really see what they do. But from what I understand, I put something on Google Classroom. For what I understand is you just click on one of the assignments, and I guess you get to choose what unit you want to do an FRQ from. And then it'll just give you practice FRQs. It'll give you like the grade rubric. So you can like look at how the question's supposed to be answered, how they grade it, like all that stuff. So maybe some of you guys can chime in on that if that's pretty much if I summed it up correctly. But like I said, I can't really see it. Like I don't really know what it looks like, but from just reading about it, it sounds really useful. And it's low pressure, right? It's not anything I'm grading. It's not anything that like it's not an actual test. It's just practice. So you can just open it up and look at it and just try to like quickly in your head maybe try to think about how you would answer it and see if you're right. So you could use this in a lot of different ways. So I recommend that if you guys have no clue what I'm talking about, go to Google Classroom. I have an update on it. And give it a shot. Let me know how it goes. All right, so if no one has any questions on anything, nothing new to report in terms of the AP test. Nothing new with the class setup, how we're doing this. Everything's kind of staying the same. Grades are going to be, so today's the first day of the 4th quarter. Congratulations. You guys have one more quarter of high school, which is kind of insane. I'm sure you guys, it's such a weird situation. I don't know if it's hit, but this is your last quarter of high school. So you guys only got a couple more months. And unfortunately not ending probably, well, we'll see. I mean, I think supposedly DeWine is going to come out either today or tomorrow. And he's announcing what's going on with schools, like what the plan is for schools. So I think we're going to get like a really good idea of whether or not we'll be back by the end of the year. Hopefully, I think for everyone's sake, we would like to at least maybe try, especially for you guys being your senior year, try to get back in school and like things back to normal a little bit. But Yeah, so this is your last quarter, guys. Make it count. Everything now, everything from last week will be put on this quarter's grade. I think you guys all ended up with an A or an A plus, but with the new grading scale, it's not going to matter. You guys are all doing your work, so your grades are very high, and you'll be fine for the quarter. After the AP test, I don't know if I mentioned this with you guys. I did with Calculus AB. I'm not sure what we're doing. It depends if we're in school or not. That'll make a big factor, but we'll find out when the time comes what the expectation is after the AP test for the last month of school, like what we're supposed to be doing. So future us will figure that out. But yeah. So you guys have your assignment already opened. It is called 2017 International Practice. FRQ. Let me go back to my notebook. Something along those lines. Like I said, skip number 1. Okay, we're not doing number 1. So you guys can see my calendar. I just want you guys to do 2 and 3 today in class. So for the next 45 minutes, do 2 and 3. If you guys get it done, awesome. We'll go over it. If not, then basically what's going to happen is whatever you don't finish during this period will be for homework. Essentially what I want to have the entire assignment submitted by Friday. So how you do that is kind of up to you, but 2, 3, 4, and 5, I want to see all those in College Board, all your work for all those in College Board by the end of the week. And I put that in the calendar. You guys can read that. I bolded that at the bottom. Okay, I think that's everything I got for you. So go ahead and get started. Obviously, I'll be here. Let me know if you guys have any questions. All right, Rachel, you said for question 2, are we going to have to find what k is, or does it want us to leave things with k in there? We're going to have to find what k is, and that's going to help us with the entire problem. So I don't think we don't need to worry about that till 2b. So if you're on 2b, that's going to be a step where you definitely need to solve for k. Yeah, Rachel, let me go over it. I would say, yeah, it's probably easier than you would think. So here's the idea. How about I just go to my screen? Okay, real quick. So you're given this graph, okay, and we got A of t and B of t. They say in part B, they say during the time interval 0 to k, and we know k is the intersection. Okay, so k occurs right there. If this was like a piece of paper, I'd mark that. That's k. Water flows into tank B at a constant rate. So that's saying that this value stays the same all the way up till B. So I know that this line is 20.5. The y value is 20.5 the entire time. Okay? I also know that they intersect at k. So A of t, right, is going to be equal to k, or equal to 20.5, because that's where it's at. So all we're saying then is this, okay? This is going to be 2b. A of k has to be equal to 20.5. If I know they intersect right there, and I know what one of the lines is right there, it's 20.5, because it tells me, then by default, A of k would also have to be 20.5. So now all I got to do is replace A of t with A of k. So I'm going to have 2k minus 5 plus 5e to the 2 sine of k equal to 20.5. And then just in your calculator, you'd plug those both in, see where they intersect during that time frame. And I'll let you do that. So I'll let you go through that, find that. But that's pretty much the setup that you needed to get. So yeah, I would say it's probably easier than initially maybe you thought. And if anyone's wondering why I knew that they intersect at t equals k, it tells you in the question. So make sure when you're reading that carefully, you got that was a pretty important piece. No problem, Rachel. Oh, I just realized that I wasn't even showing you my paper. This would be the work to all the stuff I was saying. My bad. So this is, you'd say A of k was equal to 20.5, which means instead of A of t, I just replaced it every t with k. That's my function equal to 20.5. Use your calculator. Okay, for part D, can we just look at the shape of the graph, or would you use the equation they gave us? Part D. Part D, you do need to use the equation. So, here's basically the gist of it. I'm going to pull it up real quick. So they give you what WT is. All right, and WT is going to be the rate at which the water flows into tank B. So that they give us a function for that now. We want to find what is the difference of WT and AFT, or is the difference WT minus AFT increasing or decreasing at time t equals 3.5. So I'll let you guys try it, but let me kind of just break down, what this is saying. So WT and AFT, those are both rates of change. Rate entering tank A, rate entering tank B. The question is asking what is the difference between those two rates, or is the two rates increase or decrease at specific time t equals 3.5. So what we need to find is the difference between the rate of change of the rate of change at a specific time. In other words, we're basically finding the slope of a tangent line at t equals 3.5. Okay, so what we need to look for then is we need to find what's the difference between the rate of change of the rate of change. So W prime of 3.5 minus A prime of 3.5. And the only way to get this is to use the function they gave us. And obviously you guys know we already have A of t, so. And so whenever you guys are trying to find if something is a rate of change is increasing or decreasing, you just take another derivative. And we want to check if it's positive or negative. And that'll give us our answer. Hopefully that helped, Liberty. Let me know if you need more clarification or if that's okay. All right, cool. So keep working, guys. I would like to go over it if you can in the next 15 minutes. Maybe try to finish up. I mean, don't rush, but see if you can get through at least a good portion of 3. And then I'll take a little bit of time and I can go over the answers, and that way you guys can, like, if you got something wrong, you can like take the day and tomorrow to kind of review it and see if you can figure it out. So just fill me in when you guys are ready to go over some stuff. Let me know. All right, guys, where are we at right now in terms of the problems? Three B. Okay, that's a pretty good spot. All right. I'll tell you what. Let's stop there for now. Flip over back to question 2, and I'll go through 2 through 3B, and then we'll see where we're at, and you guys might be able to finish problem 3. But I figure I'll give this to you now. So we're gonna start with 2A. Just mark down what you guys get right, what you get wrong, what you need to go over. 2A you should have gotten was 66.532 liters. Again, 66.532 liters. You could have also put 533 liters. Someone's mowing the lawn. 2B, you should have gotten K is equal to 0.892040 or some form of that. I like to keep it exact because we're going to be using K, or we did use K quite a bit in this problem. So again, K was equal to 0.892040. And when you actually solve the question, you end up getting 10.599 liters. Again, 10.599 liters. Part C, you should have ended up with 48.314 liters. Again, 48.314 liters. And then part D, which you can see on the paper here, if you guys solved that, you should have gotten negative 1.14298, which is less than 0. So that means that the difference of WT and A of T would be decreasing at time T equals 3.5. Number 3, 3A. Let me remember what I was asking. Can't remember if this was like a prove this or something question. Let me see. So it says find the average rate of change of G. Okay, so the average rate of change of G, you end up getting in the numerator 12 minus the quantity 7 plus pi. And all of that is being divided by 10. Again, 12 minus the quantity 7 plus pi, all divided by 10. And 3B, you're going to get 4, will be your final answer. Okay, we got about 5 minutes. If you guys want, I might be able to explain something really quick if you had a question. If not, that's fine. On Wednesday, my plan is to go over any questions you guys have. So Wednesday, we're going to pretty much take this whole time to do that. Liberty, why are we subtracting in 3A? Well, with the difference quotient, the overall setup, maybe this will help a little bit for 3A. Right, if we're saying they want you to find an average rate of change, we want to use a difference quotient. So we take G of 5 minus G of negative 5 divided by 5 minus negative 5. So that's just like the overall setup, so that's where the negative comes from. The way I treated it was I found G of negative 5 and G of 5 separately and then put them together. Does that help, Liberty, or do I need to keep going with that? Yeah, no problem. And just remember, whenever you guys see the word average rate of change, just think slope. So you're always going to take the function valued at both the endpoints and just make a slope out of it. That's usually the helpful hint I think of. How are we with problem 2? Did you guys get through that 100%? No issues? Because I think problem 2 might be the hardest one on this problem set. Can I go with 3B real quick? Yeah, Rachel. This one shouldn't be long. So it says find the instantaneous rate of change. 2 rock, no issues. Okay, cool. So 3B, find the instantaneous rate of change of G. Okay, whenever we're looking for finding the instantaneous rate of G, it means that we need to be finding the derivative of G. Oh wait, at x equals 3. So we need to find the derivative of G at x equals 3. Okay, awesome, Liberty. Cool. Yeah, I thought 2 was a little bit more challenging, so I'm glad that you guys got through that. No problems. It's a good sign. Anyways, we're taking the derivative at 3. That's going to be equal to the derivative of the integral from 1 to 3 of f of t dt. Right, so I got this because if you look back at the original equation of g of x, and you're taking the derivative of both sides, this is what you'd be left with. G prime of x, in this case x is 3, equals the derivative of the integral 1 to 3 of f of t dt. Which means g prime of 3 is equal to, this is the definition of the fundamental theorem of calculus. If you take the derivative of an integral from whatever bounds, all this is going to be equal to is whatever's on the inside, so whatever function value you're using, in this case it's f, of your upper bound. So f of 3. That's just by the fundamental theorem of calculus part 1. So putting that all together, you just got to find f of 3. Pretty easy to find, right? Just look at the graph. Go to x equals 3, find what y value that is, and in this case it is 4. Sound good, Rachel? Yeah, you too, Rachel. Thank you. Yeah, I know, Liberty. It is way easier than you might think. Because you got all these integrals and derivatives, you're like, oh god, this is going to be horrible. And then it just kind of cleanly just gets rid of everything. Yeah, you too, Liberty. Thank you. Ethan Thomas? What? Gracing us with his presence? To what do we owe the pleasure, Ethan? Yeah, right, Liberty. Fundamental theorem of calculus, guys, is everywhere. So definitely review that if it maybe it's been a while since you've seen that. And all you AB guys who are just jumped in, who are listening, same with you guys. Fundamental theorem of calculus is huge. I've been up since 6. What are you doing up? Since 6? Jeez. New dog and Vinny are wrestling at 6. You got a new dog, Ethan? What kind of dog is it? Well, I appreciate it, Ethan. Appreciate you having you. Always a good time on Mr. Harris's stream. All right. Let me open up our calendar. Mind what I'm doing. His name is Charles. He's a beagle mix. Aw. Did you rescue him, or is he like a purebred? Little beagle. I love beagles. Good morning, Jasmine. Bringing the sun into our chat. Gotta love it. Get a little sunshine action going. Rescue, that's what I'm talking about, Ethan. That makes me feel good whenever I see people rescue their dogs. I rescued my little mutt. He was like a little sad sack. He had a double ear infection. He wouldn't move. He just sat the first time we took him home. It was like We got them from New London. It's like by Worcester. I don't know if you guys have ever been out that way. It's a really long drive though. And we drove all this way. We found him on the internet. We're like, oh, look at this guy. Let's check him out. And he like wouldn't move. Like they brought him out into a room, and they said like, oh, his name's Bentley. They said, oh, Bentley, this is the Harrises. They might wanna adopt you. And he just sat there. He didn't move. No matter what we did, he wouldn't move. He wouldn't look at us. He just looked at the ground, and like it was the saddest thing in the world. And we have felt so bad for him. Like we gotta get him. And so we had our car set up. We took him. We had our car set up with like some like food, water, blankets for him. And like he just was so confused and lost. And at the end of the like we were like literally 10 seconds from being home. He made it the whole way. And he was at my feet, and I was like, oh my gosh, he likes me. He came over, and he threw up all over my shoes. It was the first day with my dog. He was just a sad little guy. Completely shy. He wouldn't talk to any of us. He would just howl at night. It's really sad. Now he's good. Now he's a big baby that gets spoiled every day. Good morning, Katie. Thanks for dropping by. So guys, I'm going to give some people a couple more minutes to join in. We're going to start today by reviewing College Board Unit 4, FRQ. So this was your homework over the weekend. It's due, I can't remember. I'm thinking it's due by 3:30 would be my guess. So you guys can go ahead and get that opened up. I will be doing the same. Ethan, we got Charles on Saturday, and he fought with Vinny all day, and yesterday they're finally taking naps together. Yeah, Ethan, I'm sure it won't take that long. They'll get used to each other. I'm sure Vinny doesn't like it too much, though, having like someone compete for attention. So Vinny's got to get used to that. Especially because Vinny's a little pup, too. I want to bring my dog on stream sometime for you guys. I want you guys to see Bentley. I have to have my parents drop him off or something. It's my goal by the end of the year. Okay. So Unit 4 FRQ Part B. That's what we'll be going over to start. Good morning, Alexis. How you doing? How's everyone's weekend, by the way? You guys have good weekends? Anyone do anything really fun? Okay, this AP. Oh my gosh. Hate this website sometimes. Anyone find anything creative to do during quarantine? It was good, boring as usual. Ethan, I know you were busy. Taylor said she's bored as usual. Yeah, nothing's changed. So one thing I did was I did a couple. I have a golf club up here and a bunch of golf balls, and I was just shooting trick shots in my apartment. So that was kind of fun. A good time. Kept me busy for a little afternoon. Drake and I played Call of Duty. Yeah, Call of Duty. I've played a lot of Call of Duty. Jasmine, you draw? That's cool. I have no ability to draw, but if I did, I'd probably do it. I helped my grandma shed together. Oh, there you go. At least you got outside, Katie. That's huge. I wish I had like an excuse. I need an excuse to just do something outside. I wish I had some manual labor I could do. Alexis, I got a new upgrade on my truck and washed it, but still pretty warm. That's pretty cool, though. Something to look forward to. Do you have to go to the dealership for that, Alexis? Because I don't know if they're all closed down or what they're doing with all this. Brandon, not really, but I've picked up a guitar. Oh, cool. That's a good little skill to pick up, though. Everyone wants to learn how to play guitar. It's hard. My brother's decent at it, but it's a lot of work. What's your gamer tag? We need to make a... Not happening, Ethan. Good try, though. Oh, nice, Alexis. That's awesome. That's cool, too. That's kind of like Katie. You had something to do. You got to be outside and a little manual labor to take your mind off some things. Ethan, boo. Sorry, Ethan. Teacher, student, I don't know what the word would be. Okay, guys. Finally, after 15 minutes, my assignment now is pulled up. So, here's what we're going to do, guys. We don't need you anyways. I'm pretty good, Ethan. Everyone needs me. Okay, so I'm going to show you guys the assignment, just so everyone's clear. This is when we're going to start on the, like I said, Unit 4 FRQ, Part B. I am going to go through the answers to start, and then I'll have you guys afterwards say specifically what kind of problems you want to go over. We do have an assignment I plan on doing. I mean, at the end of the day, if everyone's confused, like I'm more than happy to just go through step by step for some of this stuff. I did want to do Unit 5 FRQ Part A, but if we don't get to it or whatever, we can move some stuff back. I'll figure it out. Not too worried about it. So just be honest, like tell me what you guys want to go over. Don't freak out and like say, oh, we got to get this done or it's going to be homework, whatever. Just, be honest with me as we go. Yeah, Brandon. Yeah, the guitar does that. That's why I don't know how people play guitar without a pick. I would need one for sure. But it's still, your offhand gets raw too from strutting on the strings and stuff. Anyways, so 1A, that's where we're starting. So we're going to go to College Board, Unit 4, FRQ, Part B, 1A. No one, I think only one person in both my classes submitted it. So I don't really know, like, I don't know how you guys, I don't know if you guys were just waiting or if, how far we are in progress, whatever. Great idea. My dad versus Mr. Harris, 1v1 on Rust. There you go, Brandon. That would be entertaining. That would be something that I think people would enjoy. Okay, so 1A. You guys should have gotten, it said find W prime of 8. You should have gotten -4/5 for W prime of 8. Again, -4/5 for your answer. They explain the meaning and the context. It's meaning at time t equals 8, the rate at which the depth of the river is decreasing at a rate of 4/5 feet per hour. You can kind of say that, however you want. Most important thing to include is the time. So at time t equals 8, it's the rate at which the depth of the water is decreasing. Those are the big things you got to include. Even if you didn't get -4/5, you could have still gotten your answer correct, your meaning correct. So make sure, even if you're not confident with the answer, always answer what the meaning of the context is, because you'll get a point for that. Okay, so for B, it says the graph of W is concave down from 3 to 3.5. Use the line tangent to the graph of W to show that W of 3.5 is less than or equal to 9. Ethan, you only use the bottom equation, right? You're only worried about W. So in this case, it was t equals 8. So yes, only the bottom one, correct. You got it, Ethan. Okay, so B, the graph of W is concave down. We want to use a line tangent to show that the graph of W at t equals 3, W of 3.5 is less than or equal to 9. So a couple things you need to do here. First things first is you have to figure out what we're using the line tangent to the graph of W to show that W of 3.5 is less than or equal to 9. Whenever you guys see like decimals like this, like you're given like a whole number, for instance, you're given W3 and you want to find W of 3.5, This is kind of your hint to use our approximation formula. Okay, and our approximation formula was basically just saying w of 3 plus w prime of 3 times 3.5 minus 3. That's the approximation formula. So you end up getting 17 halves plus pi over 8 is your final answer. And that 17 halves plus pi over 8 is in fact less than or equal to 9. Okay, so part C, you're just finding a limit. You end up getting indeterminate when you direct sub, and you have to use L'Hopital's. After using L'Hopital's, go through that process, you end up getting your final answer as pi times the square root of 3 divided by 8 minus 12. So the quantity, pi times square root of 3 divided by 8, that whole quantity minus 12. Okay, that's question 1. Flip over to question 2. All right, so question 2 says, show that the velocity of the particle at time t is given by v of t equals that. So we're given position. To find velocity, you're just taking a derivative. That's all you're doing. So you just take a derivative of x at t, and you end up showing that. So just take the derivative, and you get to that point pretty easily. All right. B is the particle moving toward the origin, away from the origin. We need two things. First of all, we need to know where does it start. So at time t equals 2, where is the particle in relation to the origin? So to do that, all you got to do is find x of 2. So if you evaluate x of 2, you're going to find it is equal to negative 1/4. So my position is at negative 1/4, meaning I'm starting left of the origin. You also need to figure out which direction the particle is moving. Because if it's moving to the right, then that means it'd be moving towards the origin. If it's moving to the left, it's moving away from the origin. So you have to take the derivative, which tells you which direction it's going. If you take the derivative at t equals 2, you get it's a positive value, which means that it has to be moving to the right. We know, like when we're looking at a number line, right? We're looking at a number line, you move to the right to get higher up. To the left, you go down, negative numbers. So if your derivative is positive, it means it's moving to the right. So we start at negative 1/4, we're moving to the right. Hopefully you guys in your head, you're picturing, okay, we're definitely moving towards the origin. Okay, part C, it says the acceleration is given by a of t. Write an expression for a of t and find a of 2. Well, a of t is just going to be the second derivative of position. Or a of t is the derivative of velocity, right? It goes position to velocity to acceleration. So we have to take one derivative. We already did that. So we have to take the derivative of x prime, which is the second derivative. Use quotient rule. It's a big, wild answer. You can keep it as like the unsimplified version. If you guys did simplify, you end up getting negative 49 over 200. Most of you, I hope, answered it like this, though, so bear with me as I say this because it's a little harder to say. You should have gotten 20 squared times 70 minus 140 times 40 times 12, and that whole thing divided by 20 to the 4th, which simplifies to negative 49 over 200. But like I said, I don't care if you actually prefer you don't do that. You don't simplify. Just keep it how it's originally written. Okay, and then D is really easy. What position does the particle approach as t approaches infinity? You're just taking the limit as t approaches infinity of the function. And you have t squared, so you have the same exponent in numerator and denominator, so you just take the coefficient, so you get 1/3 as your answer for D. All right, so guys, go ahead and type away in the chat what kind of questions you guys would like to review. And I can go over those, and if not, we can get started on the next assignment. Ethan, so for 2b, you just plug in 2 into the derivative, and if it is positive, it's moving to the right. Yep, you got it, Ethan. Exactly. Whenever a derivative is positive, it's increasing. Values are increasing. Whenever the derivative is negative, it means values are decreasing, because that means the slope at that point is increasing or decreasing. So whatever the trend of the slope is, that's telling you are we moving up, down, right, left. In this case, it's specifically talking about position of a particle on a graph. So Right would be positive, left would be negative. One B and one C. All right, so let's start there. You guys can keep typing stuff in, but we're going to start with those. So let me switch my screen here. Okay. So back to number one. It says 2. This is the one that says the graph of W is concave down for 3 to 3.5. Use a line tangent to the graph of W at t equals 3 to show that W 3.5 is less than or equal to 9. All right, so first of all, let's get that point, W 3. Let's find that, because we're using a line tangent to the graph. So we need an equation of a line tangent to a graph, or at least we need the pieces of the line tangent to the graph at W at t equals 3. So if we're going to use this tangent line, we need to know what's the y value of the tangent line. So we need to evaluate W of 3. So let's start there. Okay, to find W of 3, just look back up at the given function. We're given this piecewise function. If it's t equals 3, should we be using the top function or the bottom function? Okay, you should be thinking we use the top, because 3 is between 0 and 6. So all we do, I'm not going to show the work for that. You're just going to plug in 3 in for t. Okay, and what you end up getting here is 17 halves, because that second part of the function just turns into 0. Now I need to know what the slope of that tangent line is. Okay, so I need to find what W prime of 3 is. Before I do that, just because in part A you probably did this, let me first just get what the W prime of t is. So this is something you kind of want. It's useful for the problem. So W prime of t is just taking the derivative of each function in the piecewise. So the derivative of the first function is 3 halves sine of pi t over 6 times pi over 6. And then the second one is negative 2/5 times t minus 6. And we are still in the same setups, same intervals. Okay, again, you might have done that for the first part. I know I did. I did it for the first part of the problem, but if you didn't, these are what you should have as your derivatives. So if I'm finding W prime of 3, I'm just plugging in 3 into here, into that first function there. And when I do that, I end up with pi over 4. To show you guys, because I guess this one isn't really something I need to be taking for granted. If I were to plug in 3, I'm going to be left with this. So I'm going to get 3 halves sine of 3 pi over 6 times pi over 6, which would be 3 halves sine of pi over 2 times pi over 6. Well, sine of pi over 2 is 1. So that's going to be equal to 3 halves times pi over 6. So that's how I got that answer, just in case anyone was curious, because you don't have a calculator technically for this problem. So okay, so I have all the pieces for this tangent line. We want to show that W is 3.5, so we're using this information to show that W 3.5 is less than or equal to 9. The only way to do that is to use our approximation formula, because we can't find for sure. There's no way for us to actually solve for W 3.5. Well, there is, obviously, because we have the function, but there's no way for us to use the tangent line in any other way other than the approximation formula. So we're finding the approximation for W 3.5. And like I said, we've done this before, where it's W of 3, so 17 halves, plus w prime of 3, which is pi over 4, times x minus a. Your x in this case is 3.5. So 3.5 minus whatever the x value you're comparing. In this case, it's x equals 3. And that's equal to 17 halves plus pi over 8. And we want to know that that's less than or equal to 9. And in this case, it is. We know that we can kind of just do really in our heads. We can show what's going on here. You could think of pi over 8 as just 3.14 over 8, which is almost like a half. It's less than a half is what it is. 17 halves is the same thing as 8 and 1/2. So if you have 8 and 1/2 plus something that's less than 1/2, that means you're going to be less than or equal to 9. That would be my process of how I would show that. Just treat pi as 3.14. Understand that that's less than 4, so this is somewhere around 1/2, but it's less than 1/2. All right, so that's B. That's all we need to do for B. And then Jasmine said she also wants to look at C. Well, by the way, before I go on, is there any more questions on B? Is there anything else you guys need me to talk about or discuss? Going once, going twice. Okay, so let's look at C then. So we're taking the limit as t approaches 2 of wt minus t cubed plus 1/4 divided by t minus 2. Okay, that's just the question. That's all the question's asking. First things first, let's use direct substitution. So w of 2 minus 2 times 2 is 4, 4 times 2 is 8, plus 1/4 divided by 2 minus 2. Already we should probably be a little bit concerned, right? Direct sub gave us a 0 in the denominator, but that doesn't mean it's indeterminate. Remember, indeterminate means we have to have a ratio 0 to 0. Okay, so if we evaluate w of 2, what we end up finding is, well, negative 8 plus 1/4 is equal to 7 3/4. However you wanted to write that, you could write it as improper or proper, however. Sorry, it should be negative 7 3/4. W of 2 is 7 3/4. How do we find that? Well, we just take 2 and plug it into our original piecewise function. So you guys get that proportion clearly. This is 0 over 0. Okay, 0 over 0 is what we call indeterminate, which means we have to use L'Hopital's. Okay, when you're doing L'Hopital's, you're going to keep the limit, so it's still limit as t approaches 2, of the derivative of the numerator and denominator separately. That's the number one mistake people make. Remember, when you're using L'Hopital's, you're treating the numerator and denominator as completely separate entities. Okay, you're not using quotient rule, you're just treating them completely separately. So the derivative of w of t is w prime of t. Derivative of t cubed is minus 3t squared. Derivative of 1/4 is 0. Derivative of t is 1. Derivative of negative 2 is 0. So I'm left with this. Limit as t approaches 2, t approaches 2 of w prime of t minus 3t squared over 1. Now we're going to direct substitute, so I get w prime of 2 minus 3 times 2 squared is 3 times 4, which is 12, divided by 1. So if I'm looking to find w prime of 2, I'm going all the way back up here. Remember earlier on I wrote what w prime of t is? Except in this case, I want to know w prime of 2. So I know it has to be in this first function because that's from 0 to 6. So I'm going to go back down. I'm using that function. So I'm going to be left with 3/2 sine of, instead of pi times t over 6, it's just going to be 2 pi over 6 times pi over 6 minus 12 divided by 1. That's how I would keep my answer. When I told you guys the answer, it was the simplified version. I would just write it like this. You don't need to go any farther. You don't need to simplify inside the parentheses. You don't need to do anything else. Like that, that's your answer. And that's perfectly 100% acceptable. So that would be my recommendation to you guys, to stop there. If you were to keep going, you end up getting pi times square root of 3 over 8. That's what it simplifies down to, minus 12. But why do more work if we don't need to? All right, any questions, guys, on that? So are we good? Are we ready to move on then? Go ahead in the chat. Haber, classic Haber, thumbs up. Always appreciated. If you guys feel like you're ready, we can move on to do today's assignment, then let me know. Jasmine seems to think so. Remember, this assignment's due by 3:30 today, guys, so make sure you guys submit that to me. I'm okay with the presentation of answers you have given us. Very properly stated, Ethan. I'm glad I could be of service. If that's the case, then let's look at today's assignment. So I don't know, I didn't really go over this too much detail. This is our calendar, though. You guys can see on my screen. We just reviewed Unit 4 FRQ. We are going to move on to Unit 5 FRQ Part A, and we have about half an hour. I think we should be able to get through it. You guys will have Unit 5 FRQ Part B for homework. It's not due till Friday. It is open. It's not due till Friday, so you have all week to ask me questions. Wednesday, we'll review quickly any types of questions you guys had from that assignment. So any questions you have, try to get at least some of it. Try to look at it, attempt it by Wednesday, so we can talk about it. And then Wednesday, we'll do Unit 6, FRQ Part A. For homework, you guys will have Unit 6, FRQ Part B. Friday, we'll review everything from the week, anything you guys had, and if not, we're going to just start on the weekend's homework. So this is going to be pretty much the setup, I think, for the foreseeable future till the AP test. Gives you guys a ton of practice with FRQs, and just a really good overall great review of all the stuff we've done this year. AP test, as you know, is the 12th at 2 o'clock. Make sure you guys are still looking at things, trying to review, trying to get in good shape for this exam. I will say, you guys probably already noticed, I did your final grade. So the grading period is, fourth grading period starts today. But I put in all your spring break assignments for last quarter. So if you guys are curious on how you did on those, I gave you feedback. So and if you got 100% on them, I didn't give you feedback because that just means you're doing fantastic. Good job. So I didn't have time to like write a bunch of things. But if you got stuff wrong, so if you missed points, every single time I took a point away from anyone, I explained why. So if you guys go into College Board, review the assignment, because I turned them all back into you guys can see all my comments and understand like where things went wrong or where you missed points, which is a really useful thing to do. If you got 100%, that means on an AP test you would have also gotten 100%. So you should be proud of that. That's how I'm going to continue to do these assignments. I want you guys submitting pictures. One thing I want to talk about real quick is with the pictures. So a couple things. Number one, make sure it is a clear picture. And I know it's not easy, but I think these computers are good enough computers where they can take clear pictures. If not, just use your phone and email it to yourself. That doesn't take too much time, pretty easy. But I know a lot of you guys have like nice phones, so you can do that. But some of you guys, and I commented on a lot of you who gave me issues. Some of you guys, your pictures weren't very easy to decipher. Also, this one hits home to me because I can relate to this. Not all of you have very neat handwriting or very neat work. It's different because I'm your teacher and I've seen your work all year. So for me, I'm pretty good at being able to decipher what you're trying to say. The AP graders could be 60-year-old retired math teachers, all right, that need like the highest powered glasses that money can buy, all right, just to see. So if you're expecting them to try to find and like try to analyze your work in like a tiny, tiny little font or in a picture that doesn't really zoom in, that's like zoomed out, it's not going to happen, and that's not good. You don't want that situation. So here's what I've been saying. If you can get a clean picture, if you can take a picture of your page, and it's very easy, very readable, the font is big enough for me to see, I don't have to zoom in, I can just like look at it. If you're confident enough with that, you can take one picture and just upload it for the questions, and that'll be good. I don't mind that. I know originally I said I wanted to see each individual part for each individual, like submit a picture for each part, which actually I don't hate either. So those of you who did that, if you want to keep doing that, it's really easy for me to read, which I prefer a lot, and it's nice to really like dissect each individual part separately. But if that's annoying, I could see how that'd be annoying. Just as long as it's like I need to be able to read it. I need it to be neat. I need to be clear. I need you to make sure the whole page is on the picture. A couple people took pictures and I didn't get to see all the work because the picture cut off some of the work. So just keep these in mind. And the reason I'm being stingy about it and picky about it is just because, I want you guys to not, for the AP test, I don't want you guys to make any mistakes like that. So work on that now. I personally think the best way to do it is to just write each problem like in really big font, like take up half a page for each problem, no matter how little work you have. Write it big, write it clear, be very descriptive and specific with everything you do. If you have different colors even, write them in different colors, like different pieces, and then just take a picture of all that work and upload it for each individual part. That's the neatest way to do it. And like if for the AP test, I would consider doing that, but it's not a huge deal as long as it's legible. So thought I would tell you guys that. But in terms of the actual responses, most of the people in this are the ones who did the assignment, if we're going to be honest. But you guys did a really good job. So keep that up. I'm very, very happy with the work I saw. So hopefully it's helping you a little bit. I think that's all I want to talk about right now. Okay, we don't have that much more time, right? It's already the 20th. We have our test on the 12th. So 3 or 4 more weeks, and you guys will be taking the AP test. So keep that in mind. Ethan, what are your plans after AP test? Dreams of you playing Rainbow Six? Yeah, you got it, Ethan. I'm gonna finally get to do my dream and be a full-time streamer. Can't wait. The only thing in my way right now is you guys. No, I'm just kidding. I don't know. That's a good question though. In all seriousness, I don't know what we're doing after, because it depends on if we're gonna see each other or not. Because if we're over stream, things are gonna be a little bit different than if we were in person. I gotta talk to Mr. Snook and administration and everything and figure out what the game plan is for all that. So I'll keep you posted. Okay, so yeah, that's the week ahead. Thank you for putting all the hard work in. I promise this will benefit you. I know I'm assigning a lot of stuff. I know these FRQs can be a big pain in the butt. I get that, but that's the point. That's why I'm giving it to you. because it's uncomfortable, it's difficult, and we need that because that's what the AP test is. So the more and more I can give you before the 12th, I think the better off you guys will be. Okay, so this is the assignment we're going to be working on now. This is Unit 5. FRQ, Part A. Let me go to my hover cam here. Whoops. All right. So go ahead really quickly. Give me a thumbs up or a good or something in the chat so I know everyone's got their assignment up, ready to go. I can get started. All right, cool. Thank you, guys. All right, so this is what we got. Not too much words. Okay, there's not really much going on. This is what we're given. We're given that f is a twice differentiable function. We know that f prime of 1 is equal to 0. We know that f double prime of x is equal to that function. And we know that the interval is from -1 to 3. Okay, that's all given to us. Everything I wrote there is given to us. Not anything you need to write down for your work, but I like to keep everything together. All right, and the first question, 1A, it says, on what open intervals contained from -1 to 3 is the graph of f concave up? Okay, well, let's first evaluate what does it mean, or what are we looking for the graph to be concave up? Okay, we're only given one thing. We're given a couple things, but we're given only one function, and that's the second derivative. So we want to know, when is it concave up? What do we have to see on the second derivative for us to know it's concave up? Well, concavity is determined by the second derivative. So this actually works out really, it's in our favor. It's working out in our favor because we have the second derivative. All we're looking for to check concavity is say, well, what is the second derivative? Is it negative or positive? In this case, concave up is when the second derivative is positive. So that's all I'm looking for at the end of the day. I just want to know, when is f double prime of x greater than 0? Now you might be thinking, Mr. Harris, okay, this is kind of a complicated function. I don't know, how am I going to do that? Do I just pick numbers? Do I just guess? And Mr. Harris would say, no, that's really stupid. Why would you say that? No, I would never say that. But no, don't do that, because this problem has a calculator on it. We can use our calculator. So I'm so responsible, and I already have it plugged in. So you guys, what we're going to want to do is we're going to want to just graph that. If you can't tell, let me put that down. That's the second derivative. We want to graph the second derivative. If we're looking for one that's positive, all we got to do is graph it. Make sure your window's right. So make your window like from, in this case, -1 to 3. I'd do maybe -2 to 4. Okay, and then we just look at this graph, and we got to find some spots where it's positive, or all the spots it's positive. So think to yourselves, how could we do that? Well, the key is that we got to figure out, when are those intersect? When does it change from positive to negative? So what you're going to do is you're going to go to second, calculate. Let me go back. Okay, so you go back to your graph. You're going to go second trace. That'll bring you to calculate. In this case, we want to know the zeros. We want to know when it switches from positive to negative or negative to positive. So I can see, like visually, I can see where it's at. I know one of them is over here. And the first question says left bound. Second question says right bound. It gives you a guess, skip through that. You press enter, and it gives you where it switches. So we know that our first answer, our first interval, is going to be from Oh, wait a second. The interval is only from -1 to 3. I know it's going to be hard for you guys to see, but hopefully in your calculators, if you're following along, I got one of my zeros at x equals -1.253. That's not good, right? Because that's not in my interval. So I'm just going to ignore that answer. That answer doesn't mean anything to me. Okay, so that means I'm going to check the next one. So I actually expanded my window. My window was a little too small, so I expanded it a little bit. Okay, so these ones we're ignoring because it's not in our interval we're looking for. So let's go this way. Okay, I see another one over here. So I'm gonna do the same thing. I'm picking up my calculator because it's easier. I do left bound, right bound, and I find that it's at positive 1.253. So you can see maybe my little dot there. And I want to know how long does that stay positive. So I got to find the next zero. So I'm going to do another intersect. Another zero. Do left bound, right bound, enter, and you get that's till 2.171. Okay, and then there's another one. You're going to do the same process. The other intersection's at 2.802. And it turns negative at 3. So I'm just going to stop real quick. Let me know, are you guys okay with the calculator? Like, a lot of times I find myself, like, forgetting that. It's really important that we know how to do it, and I just kind of assume that you guys are okay with it, which is stupid of me. So let me know if that process is all right. Remember, for the AP test, you guys will have your calculators for every problem, so they can be really valuable to you. I think the internet's allowed, so you can use Desmos too for some stuff, or any other calculator you might know of. Okay. So yeah, that's how you go through that problem. The biggest thing, guys, for these, and this is the issue I remember when we actually went over this unit with concavity and inflection points and critical points, maxes and mins. Understand that second derivatives are always with concavity. If you see anything that has to do with concavity, it means it's the second derivative of the function. Okay, so in this case, our function is f. If we want to find the concavity of f, we have to take the second derivative. And so a positive concavity or a positive second derivative is a concave up, negative second derivative is concave down. All right, 1b. 1b says, does f have a relative minimum, relative maximum, or neither at x equals 1? Look at that. I just read the future. All right, so let's put some pieces together. We're worried about at x equals positive 1. That's what we're worried about. And we're looking for minimums and maximums, which means we're looking really at the first derivative. Okay, so let's look at what's going on with the first derivative. So f prime of 1. How do we find that? Well, it's given to us. If you guys look in the question, it says let f be a twice differentiable function such that f prime of 1 equals 0. That's pretty easy. All right, now here's the issue though. Okay, so this is all fine and dandy. I'll highlight that. That's good. Good to know. What does that say? What does that mean? Well, guys, remember, when we're finding critical points, that's when the derivative is equal to 0. Guess what? The derivative is equal to 0. So all this told me, doing this, all it told me was that there's a critical point at x equals 1. That doesn't help me on whether it's a minimum or maximum, though. Normally what you guys would do would be make a table. You'd make a table that would have like intervals, right? And we would do signs. So it's like a sign chart. And you guys would see, oh, is it increasing then decreasing, or is it decreasing then increasing? Like, how's that happening? which is all great, and that's a great strategy, but guess what? We don't have f prime of x. We don't have the function. We don't know what it is. So we can't just plug in values and see what's going on. So we got to be more creative. What we do have is the second derivative. We're given that. So let's find the second derivative of 1. That's going to tell us something about concavity, which is really useful. So all you do, guys, go into your second derivative function, plug in 1, and you get it is a negative number. Notice I didn't give a value. I don't care about the value. If you plug in 1, you're going to get cosine of 1 plus pi. So f double prime of 1 is equal to cosine of 1 plus pi. Well, if you guys look at the unit circle, so if we're looking at the unit circle, here you go. Mr. Harris's horrible unit circle. Pi is over here. 3 pi over 2 is over here. Cosine are all the x values. Cosine of 1 over pi lies somewhere in this quadrant, in quadrant 3. Which means that all of my x values are negative there. So I don't care what the value is, it doesn't matter. All I care about is the fact that it's negative. How do I know that? Well, I know that pi is 3.14. 3 pi over 2 is like 3, 6, 9, 9 something over 2. So if you add 3.14 plus 1, you get 4.14. That is going to definitely be smaller than 3 pi over 2. But I have a calculator, so it doesn't even matter. Now Mr. Harris just realized he had a calculator's problem, and this is all unnecessary. Just put in your calculator. Sorry for wasting your time. But that's if you didn't have a calculator, that would be reasoning that you could use. Okay, so what was the point? Why did we do that? Well, now I know that there's a critical point, and I know that it's concave down because the second derivative is negative. So that's concave down. The only type of maximum point or minimum point that can occur, or the relative point that can occur when it's concave down, is at a relative max. And then we can say our justification is by the second derivative test. Sorry, my handwriting is getting really bad. Getting kind of lazy right now. It's laying back to my chair, and I just realized how horrible it looks. So we just did the second derivative test. That's what we just did. The second derivative test says if we can prove that f prime of x is equal to 0, then if f double prime of x is greater than 0, then it's going to be a minimum point. If f prime of x or f double prime of x is less than 0, it's going to be a maximum point. That's the definition of the second derivative test. So that's what we did, and I'm sure you guys have done that before, and like you can get it conceptually. But your justification is just say that that's what I used. I used a second derivative test. And the only way you can use a second derivative test is if you can prove that f prime of x is 0, which we did. All right. Let's keep on rolling. 1C. All right, so let's break this one down. It says, use the mean value theorem on the closed interval -1 to 1 to show that f prime of -1 cannot equal 2.5. All right, so mean value theorem, guys. Been a little bit of time. Okay, so the mean value theorem was saying that if we can find, we're basically looking for f prime of x to be equal to the average rate of change. So where is the secant line equal to the tangent line? Sorry, where is there a tangent line that has an equal slope of a secant line? In other words, when does the instantaneous rate of change equal the average rate of change? Okay, so that's a reminder of what it means for that's what the mean value theorem is stating. Mathematically, this is what we're basically breaking down. So we need an average rate of change. Okay, our average rate of change is going to be equal to, because it says our interval is from -1 to 1. So I need to find what f prime of 1 is, minus f prime of -1 divided by 1 minus -1. Remember, an average rate of change is just slope over an interval. So it's your y values minus or divided by your x values. Brand, I don't know if you're like a long bit back in the question. I don't know if your stream's up to date, or maybe I'm just misunderstanding your question. So if you can clarify that, I'll go over it. So yeah, we can talk about that, Brand. I'm gonna keep going with this. We're running out of time a little bit, but I think maybe clarify what you're asking. Okay, so we know that we're looking at this. Okay, they give us that our assumption is, so if f prime of -1 equals 2.5. So that's what they're saying. They're saying they want us to show that f prime of -1 can't be 2.5. So let's say it is. Let's say if f prime of -1 is 2.5, then that means I'm going to be left with my average rate of change is going to be 0 minus 2.5 divided by 2. Which is equal to -1.25. Okay? So that's our average rate of change. We just found our average rate of change right here. I got the 0, by the way. It was given to us. F prime of -1's, or F prime of 1 is given to us as 0. So that's where I got that from. We just found 2.5 is f prime, or we're assuming f prime of -1 is 2.5. Okay, so now we actually want to evaluate, or we want to use the mean value theorem. So by mean value theorem, because f prime is differentiable, it is also continuous. Hopefully we're okay with that idea by now. Any function that's differentiable is also continuous. So actually, I'm going to erase that part. I'm just going to say because f prime is differentiable is also continuous. So we have to prove that, because after we prove that, now we can say by mean value theorem, MVT, there would be a number C in the interval -1 to 1, such that, now this is where we actually apply the mean value theorem, such that f double prime of C is equal to -1.25. So we do like a lot of this kind of like, I don't know, little work just to get to this idea. By mean value theorem stating, assuming that f prime of -1 is 2.5, then we know that f double prime, there has to be some point C where the second derivative is equal to -1.25. All right, so what do? How can we show this? Show it's true or it's not true. In this case, we have to show it's not true because that's what the question asked. Well, do we do that with our graph? This is my graph of f prime, f double prime. So if I look at this, I'm looking at the interval from -1 to 1. So I'm going to change my window to -1 to 1, zoom in on my graph, and I'm going to see, is there any point where that graph hits -1.25? And if I were to zoom in even further, like for me it's very clear, but for you guys you might zoom in a little further, there is no point. So this does not happen. So there is no value of C on graph that makes this true? Okay, so that's probably the most complicated question on this assignment, using the mean value theorem. We haven't done that in a while, so that's a good review. Okay, and then the last question. Don't worry, not going to take very long. So it says, does the graph of f have a point of inflection at x equals 0? Well, actually, I have a perfect way to tell this. Remember, points of inflection, those have to do with concavity. Specifically, a point of inflection occurs when concavity changes. So wherever it goes from concave up to concave down, or from concave down to concave up, that would be a point of inflection. So let's look at my graph. I actually have a pretty good graph right now. At x equals 0, does my graph change signs? And it doesn't. It stays negative, negative, negative. It hits 0, and then it stays negative some more. So our final answer would be this: f double prime of x does not change sign at x equals 0. So there is not a point of inflection. And that's it. No work needed. Just need to use your eyeballs. All right, perfect time. That'll wrap up the class. So any questions you guys got? Algebra 2 is going to be starting here, but I will have my office hour from 1 to 2. So I'll be back on at 1. You guys can hop in real quick, ask any questions you got on this assignment, on your homework, whatever. Tomorrow, right, no stream. You do have a homework assignment. It's going to be Unit 5 FRQ Part B. Try to get that a little bit done, so on Wednesday we can talk about some of it. I will see you Wednesday. That'll be my next stream. So Wednesday at 10 o'clock, I'll be back on. So I hope you guys you calculus guys have a great day. Always feel free to email me if you have any questions throughout the week. Have a good day, everyone. Thanks, guys. Stupendous day. I like that. Jaden, good morning. I'm doing good. How are you doing? Jared, good morning. How was your guys' weekends? Good, bad, ugly, horrible, fantastic? A little bit of everything? Algebra 2. Figured I'd show myself, not be so shy. Brandon said it's delayed. Okay. Yeah, Brandon, you must be delayed like a ton. Let me see if Brandon will read this message and then hear the volume way later. Okay, hopefully I don't know if Brand's hearing my voice or if he'll see this message, but Jared had to clean out the garage. Yeah, you know what, Jared? Honestly, though, I was thinking about this because Calculus was saying that they had they did some chores, and I was thinking to myself, like, I right now I could go for some chores. I wish I had like an excuse to like go clean something, or I cleaned my bathroom this weekend. I cleaned my apartment really this weekend, but I sometimes I like doing stuff like that, like moving furniture, cleaning out a garage, washing cars. Like sometimes like that menial labor can really like ease your mind. It's a good way to keep yourself busy. Oh, cool, Jaden. That was nice of you. Yeah, see, that's stuff I kind of well sometimes it gets tiring after a while, but it's nice to keep your hands busy and get some physical exercise and be outside. Jared, you have to clean it out. Well, if you didn't, you had to clean the garage, but you didn't have to clean it out. What did you have to do? You have to like just like dust it or something. Jaden, you're probably sore moving if you had to move like heavy furniture and stuff. You're probably feeling it. You broke your ankle. What the? What did you do, Jared? Also, yeah, I'm a little confused. So you didn't clean out your garage. If you had a broken ankle, I can't imagine you were forced to clean out a garage, right? Would hope not. Man, breaking ankles. Were you playing basketball with Michael when he crossed you up, Jared? That's what I'm picturing. Oh, I was close. Fell on a basketball. Okay. So maybe it wasn't Michael crossing you up, but it had to do with basketball. Jeez. Sorry to hear that. Hope it gets better. Those are the worst. Being a basketball player, I've hurt my ankles probably over 20 times. I've hurt my ankle in some way, whether it was a minor sprain, major sprain. Never broke it though, which is insane. Seriously, I believe it. I bet Michael would say he did, Jared. No, you're not sore, Jaden? Good for you. I remember when I was in high school, I worked for a moving company. And so, basically all day, every day, I was, if I didn't like have some odd job to do, I was mostly moving heavy stuff. And I was eating like 2 lunches a day because I was so hungry because I was working so hard. And I was like sore constantly, lifting like pianos, lifting giant dressers, all that boxes of stuff. It was probably one of my favorite jobs though. I loved it. Jared, he'll try. Oh, there's Michael. Here you go. I wish. No, me and Aiden asked, what's his vertical? And he put the ball right in front of me, jumped and hit the ball and fractures. Oh my gosh, Jared. Ah, Jared. Rookie mistake. Always move the ball away when you're jumping. That's why people stop games when the ball rolls across the floor. All right, guys. So go ahead and turn to page 531 in your books. That's where we will be starting today. Look, I thought I moved it. All right, Jared. Fair enough. Put the opposite. Yeah, he put the round obstacle in front of him to land on it. Yeah, if you try jumping and land on a basketball, clearly not a very easy task to do. He probably just did it so you have to clean the garage. Jared's probably like, I'd rather sprain an ankle than clean a garage. All right, so guys, turn to page 531. We'll get started here in a second. Give people like a minute or two more, because I know how Algebra 2 can be sometimes. You guys can be slackers, sleeping in, even though you're the latest lecture. Speaking of Aiden, where's Aiden? He's usually here. I haven't seen anything from him yet. See, Digidio, Jared, Jaden, Michael. Okay, so those are my usual 4 for sure, and it looks like I have 3 more. So I wonder who else is here. Maybe who else is here a lot of times? Sometimes other Jaden is here, Booth. Sometimes Haley Mayer's in the chat. Every once in a while I'll see her pop up. But I think she's just being quiet. I don't know if she just doesn't want to participate sometimes. Sierra. Yeah, Sierra is usually here. That's my usual group. He doesn't wake up till like 1. He does a good job. He's usually at my streams. I see Aiden pop up quite a bit. Every once in a while Isaac will come out of the woodwork. All right. So we good? You guys want to get started? You guys got your books open, ready to go? Give me a little thumbs up in the chat, or I'm ready, or something, so I know. Yes? No? Maybe? I think we're just ignoring Mr. Harris. Which means I'm just not going to listen. I'm just going to go. I'm going to do it. So you guys can see I have the calendar up on your screen. Let's start there. Similar plan as always. I think this lesson, thank you, Sierra. I think this lesson is extremely beneficial. So I really like 8.1. I think 8.1 is a very useful unit. And I think it covers a lot of different important parts of algebra that I would like to focus on. And it's just good practice. So my plan is we're going to do 8.1 the rest of the week. You guys already started it last Wednesday. So you guys looked at 8.1 last Wednesday. You had an assignment that I actually don't really remember what it was, if I'm being honest. Let me see. What did we end with last week? Okay, the Alex. All right. So yeah, we had the Alex assignment. I think it was like 8 questions, not too large. I looked at it. It looked like a good amount of people did it. So I'm not going to review it. I don't know when it closed. I think it probably closes today at some point. So if you guys have questions on it, go ahead and ask. During the office hour or at some point, you can email me if you have a specific question. But I was here Wednesday, and no one really, very few people were here in the stream. So those of you who were here, I think it was like 3 of you guys, 4 of you guys. We went over some stuff. But yeah, I haven't heard about anyone else for Alex. So I'm just going to assume you guys are good with it. And so we're going to start with 8.1 today, the second part of our notes. And then we're going to have an Alex assignment. It's already been assigned to you, so it's already up and open. So 8.1 practice, Alex, part 2. This one's going to be a little bit more harder and a little bit more questions. So it's not going to be like a 2-minute assignment. It'll probably take you a good 30 minutes for sure. Yes, Jaden, you can still turn in page 513. So 8.1 practice. Alex will be homework, and then tomorrow we don't have stream. You guys know that now. Wednesday we'll have a stream again, and on Wednesday what I'm going to do is I'm going to have a study guide for you guys. So we're going to do as a stream, we're going to work on the evens. We're going to try to get some of those done. So I'm going to show you exactly how to do these problems. Just be extra practice, good stuff. And then for the homework, you guys will have to do the odds. And then Friday, as usual, is just a review day. So Friday, we review everything from the week, any questions you guys may have for the week. That's the plan. We're taking things a little slow, okay? I know usually if this was actual school, we'd be 5 days a week. We are all so smart. Mr. Harris would be flying through these lessons. You guys would be doing calculus by now. But we're in this situation. We got this pandemic, so it's going to be a little bit slower paced. And I really want to make sure that going into your classes next year, depending on whether I see you guys again, if the assumption is I don't see you again, I want to make sure that there's certain topics that you guys have good fundamentals on. And this is one of them I think is important. So I'm taking extra time on it. Good to see you, Damon. I'm glad to see that you made it. All right, that's the week. That's the week to come. No homework over the weekend because I'm a nice guy. So let's look at page 531. Turn there. And while you are turning there, I'll give you ample time and I will start talking. So what we're doing, as a reminder, rational expressions. Okay, rational expressions. What are they? What do we learn? Okay, and we learned last week what a rational expression was. And a rational expression is a fraction made up of polynomials. So you have a polynomial in the numerator and you have a polynomial in the denominator. That's how we can determine whether or not it's a rational expression. And this is just another one of our tools that we're adding to our types of functions. Okay, we've talked about so many different types of functions this year. That's what algebra is always about. And so now we're introducing this idea of a rational expression. And, we might have a rational equation as well down the line. But for right now, we're just working with these expressions. And part of rational expressions, one big piece of rational expressions is being able to manipulate them and simplify them. And you might remember last week, Wednesday, we did some simplification. And it was basic simplification. It was just taking here, actually I can scroll over. It was saying, okay, if I have a polynomial in the numerator and denominator and I factor the numerator and denominator, I can cancel out similar terms. So like a little example is a standardized test practice, right? You can factor the insides of these parentheses and see if anything crosses out. Okay, this is another example. So like example 3, right? You have these situations. So you have this rational expression. And the goal is we want to simplify it. So to simplify, you can cancel some stuff out. And they did that by multiplying the numerator by -1 and then seeing what matched. That's what we do when we're simplifying rational expressions. Another little piece that we're going to start out with today is simplifying still. We're still going to simplify. We're not solving, we're simplifying. But we're simplifying rational expressions that are being multiplied and divided by one another. So we're multiplying and dividing rational expressions and see how maybe this differs a little bit. So you guys can see at the top of page 531, they give you this table, this key concept table. And they talk about, in different variables, what we're doing. You don't need to copy this down, that's okay. But I'm gonna kind of look at it, read it after I get a drink of water. Okay, so multiplying. To multiply rational expressions, multiply the numerators and multiply the denominators. That's really important. It's just a fraction, guys. We're treating it just like a fraction. Okay, when you have a fraction, 3/5 times 6/7, you multiply the numerator together, you multiply the denominator together, that's your answer. The exact same idea here. You're multiplying two fractions together, don't care what kind of expression they are, you multiply the numerators together and the denominators together. All right, so we're going to take a look at and practice that a little bit. The next one is dividing rational expressions. So to divide rational expressions, you multiply by the reciprocal of the divisor. Again, hopefully this isn't foreign to you. Okay, because when you're multiplying or you're dividing a fraction by a fraction, for example, 1/5 divided by 2/5. Okay, let me actually, why not? Let's go to my hover cam here. All right, so you don't have to write this down. Just pay attention as I do it. Oh, I don't know why I'm writing in a pencil. Hold up. This will be better. You guys can actually see it. 1/5 divided by 2/5. Just a normal fraction, right? Whenever we're dividing by fractions, hopefully you guys remember we multiply by reciprocals. So instead of 1/5 divided by 2/5, we say 1/5 times 5/2. So we flip that second fraction. Flip that over. Okay, and like I said, if you're multiplying fractions together, you multiply the numerators. So 1 times 5 is 5. And denominators, 5 times 2 is 10, which is 1/2. Okay, that's the idea. We're doing that. That's all we're doing today. And that's what 8.1 really is hitting home. But the issue, I guess not the issue, but the difference between this problem and like the one you're going to see is that we have a whole expression. So it's not just like numbers. It's not just constants. We're going to actually have a whole expression that we have to multiply together. And I don't think there's any more I really need to say. I think now is just a good time to practice. All right, so I'm going to go over example 4, A and B. I know they have the answer in the book. I'm going to do it differently than that because it's a pain to write out what they write out. So in your notes, guys, this is just 8.1, notes continued. However you guys write that in your notebook, you're old enough where I kind of give you that freedom. Title it whatever you want, however you want to keep it organized. And this is going to be example 4, little a. Is what we'll start with, which is 6c divided by 5d times 15cd squared divided by 8a. And the question in the book just says to simplify. We want to simplify. And whenever you think simplify, you think canceling. We want to cancel some stuff out. And to cancel some stuff out, we have to find what's similar. All right, so my first step is I want to actually multiply these together. So 6 times 15. Did I do this problem, by the way? I think I did do this problem like really quickly at the end of the class. If you guys were here, can you guys let me know? Pretty sure I did. Okay, that's what I thought. Thank you, Sarah. All right, so you guys should already have this in your notes. You're going to multiply them together, numerator and denominator, and then you're going to cancel out the terms that you can cancel out. So let me actually, we're going to scratch 4a. We already did that. Let's do 4b, because I'm positive we don't. That's okay, Sierra. This one will kind of help you. It'll cover exactly what you would for 4a. So this one's 18xy cubed divided by 7a squared b squared divided by 12x squared y divided by 35a squared b. All right, so this is 4b for you guys. So we have a rational expression divided by another rational expression. Okay, whenever we do that, instead of dividing by a fraction, we always change it. So we're going to keep the first term the same. But instead of divide, we're going to now multiply. We don't divide fractions. We multiply by reciprocals. And the reciprocal of 12x squared times y over 35a squared b is 35a squared b divided by 12x squared y. Never divide by fractions, always multiply by reciprocals. Now there's a lot of ways you can go from here, guys. There is a lot of ways. Personally, because we have our calculator, and this is the only reason why, it's because we have a calculator. And your calculator is going to be available to you quite a bit. So if that's the case, I'm fine with just multiplying everything out. If you don't have a calculator, you have to be probably a little bit more strategic. Because I don't know about you, but I don't know what 18 times 35 is off the top of my head. All right, just going to be honest, I don't know. So I maybe could figure it out, but that's a lot of work. So if that was the case, I would have to be more creative to simplify this. But let's just understand that we have our calculator for this. So I'm going to multiply 18 times 35. And I'm going to get 630. X times, well, there's no other x's. So x just stays x. Y cubed, there's no other y's. So we keep y cubed. A squared, no other a's. And b, no other b's. So when I multiply across, I get 630 x, y cubed, a squared, b. Denominator, I have 7 times 12, which is 84. Again, a squared by itself, b squared is only b, x squared, only x, and y. Now let me go to my screen real quick, and I want to show you guys something I think could be useful. Now, I don't like to do it, but if you like to, I don't mind at all. So if you guys look in the book, look at this problem. So they're doing the same thing we're doing. Only difference is they broke up the 18 times 35 in a much different way. And the bigger thing, the more thing I want to focus on is they wrote their x's and y's instead of x and y cubed, they write it as x times y times y times y. And the reason they do that is because then they can physically see themselves canceling out different variables. So if that suits you better, if that looks like that would be beneficial to you, that would help you, then absolutely do that. So if I wanted to, I can rewrite this as 630 times x, y, a, b, over 84 AA BB XX Y. Sorry, didn't realize it was on that. So I can rewrite that like this. This is what they do in the book. So regardless if you go from here or from here, you're going to get the same answer. Okay, so I can see I have an x up here, and I have an x down here, so I can cancel those out. I have a y up here, and I have a y down there. I can cancel those out. I have an a, I have two a's up here, I have two a's down there. I can cancel those out. I have a b and a b. So every single thing that has a red line through it turns into a 1. So I'm left with 630 y squared, because y times y is y squared, divided by 84 b. x, sorry, bx. There's a little x that I forgot. Okay, and then if you guys want, I don't know if your calculators will do it. Like if you have a smart calculator, it will. But I don't know if the scientific calculators will allow you to simplify fractions. But I'm gonna go here to Desmos, and I'm gonna put 630 divided by 84 because I want to get this fraction simplified. So if I press that button to the left, it gives me the simplified version. So to make this like the best simplified answer, it'd be 15 y squared divided by 2 bx. All right, so that would be your final answer there. There's a little, so even if you don't have a smart calculator, you can go to Desmos. Desmos will do the work for you. Okay, so let me ask you guys, do you have any questions? Start there. And if you don't, just tell me no or say you're good. Thank you, Sierra. Jaden said good. Thank you, Jaden. Good. All right, cool. Thanks, Judea. All right. Okay, my next question for you guys. What method do you prefer? In other words, do you guys like to do you guys like to go from here to your answer? So keep them as like x's and y cubes and a squares, keep them like this and then get your answer? Or do you guys think it's easier to write out your variables? So press 1 for keep squares and cubes, and then 2 for write out all the variables. So just type a 1 or a 2 in the chat. Sarah, Sarah, you like to see them get canceled? Okay. Jaden, you said you prefer not to. Okay, so you're able to just go from step to step. Sarah, same thing. Keep the squares and the cubes. Okay. Hall brothers, if you guys are still here, what do you guys think? Haley, what's your opinion? Damon, what's your opinion? One. Okay. Okay. So it looks like for the most part, people are okay with going from here, saying, "Oh, I have 1b and 2b's." That means I'm left with 1b in the denominator, and go from there. So that the reason I ask because I want to know if I'm able to kind of skip this whole process of writing all the variables out and just go from here to there when I'm going over my work. So that's good to know. Okay, so what I want to do, guys, is I want you guys to get a little practice while I'm here. So to kind of test yourselves, I want you to do guided practice for capital A. And then I want you to Type your answer in the chat when you get it. All right, so that's the question that's given to you. And it wants you to simplify. I want to see what you guys simplify it down to. So write your final answer in the chat. Thank you, Sierra, for your submission. Jury's out if you're correct or not. We'll find out shortly. A lot of pressure, I know. Jaden, same answer, just different, written differently, but the same answer as Sierra. Interesting, interesting. Okay, guys, a couple more minutes. All right, Jared, looks like 3 of the same answers in a row here. Are they correct? Stay tuned to Mr. Harris's stream to find out. Dun dun dun. All right, let's do this. So, first things first, we're multiplying, not dividing, we're multiplying. So whenever you're multiplying fractions, you just multiply numerators and denominators together. So we got 14 times 12. 14 times 12, which gives me 168. C cubed, well, my voice, woof. C cubed, there's no other C's, so just stays C cubed. Man, what is going on with me today? Ugh. All right, D squared, no other D's, so d squared stays the same. A squared, no other a's, so we keep a squared. B, no other b's. Okay? 21 times 8, we get, oh, would you looky here, 168. A, B, C squared, D. Well, this is fun. Get rid of that, right? What else can I get rid of? B. That's good. I have two D's up at the top in the numerator, one D in the denominator, so I'm left with a single D in the numerator. And I have two A's in the numerator and one A in the denominator, so I'm left with one A in the numerator. So any form of this, CDA, ACD, ADC, DAC, DCA. Now I'm just kind of think I'm repeating myself. But any way you manipulated those three letters didn't matter because it's all being multiplied. So good job, you three that responded. You other three that didn't, shame on you. You guys are being shy or just not listening to me. It's okay. We got our three all-star students right here. All correct answers. All right, let's try another one. Now I want you guys to do, got to practice for capital C. And when you get your answer, try your best to type it in. This one's not going to be as easy to type in, but I think it'll be doable. I think you can get your point across of your answer. Two t squared divided by 9a squared. Okay, Jaden. It's Jaden, same answer. Good. Anyone else? Oh, there you go, Sierra. Okay, so I think maybe Sarah, you might have had it right. I think just you might have forgotten something. Yeah, okay, that's what I thought. All right. Okay, so Jared's is a little bit different. Good. All right, so we got a little bit of difference. Cool. I'll give you one more minute just in case. Because I know there's other people in the chat. I just don't know. They're not responding. So I'm gonna write the question down. We'll get started. So that's 16mt squared divided by 21, a to the fourth b cubed. Now this is important. I'm now, instead of dividing by a fraction, we always multiply by a reciprocal. So times 7a squared b squared divided by 24m cubed. Okay, cool. All right, so let's start multiplying numerators and denominators together. So 7 times 16 gives me 112. M is by itself, t squared is by itself, a squared and b squared. 21 times 24, gives me 504. A to the fourth stays, b cubed stays, and m cubed stays. All right, and so 112 divided by 504. If you simplify that fraction, you're going to get 2/9. So I'm just going to write that out, 2/9. Okay, look at the m's. I have 1 m in the numerator, 3 m's in the denominator. So that means I'm left with 2 m's in the denominator. I have a t squared in the numerator, no other t's anywhere. So t squared stays in the numerator. I have a squared and a to the fourth, which means I have a squared down in the denominator. I have a b cubed and a b squared, so that means I have a b down in the denominator. So my final answer is any form of this again, where you have 2t squared in the numerator and 9m squared, a squared, b in the denominator. So it looks like everyone got that. Except for Jared, it's not m to the fourth. So just double check. I think you accidentally added an m to the denominator instead of subtracted an m from the denominator. Easy mistake to make. You know, Jared, I don't know if I can forgive you. I'm gonna try my best to forgive you on that one, but really was disappointing to see that that's what happened. Very, very disappointed right now. Okay, everyone. About 13 more minutes. We're gonna do one more thing that's gonna help you with your Alex assignment, and then we should be good. Okay, so I want you guys to look at page 532. So I'm gonna put it on my screen too. Okay, and I'm going to talk about this first part. And then we're going to move on to the next part. You're good, Jared. Okay, so sometimes you must factor the numerator and the denominator first before you can simplify a product or a quotient of rational expressions. All right, so if you guys look at this problem here, we have a polynomial divided by a polynomial still. So these are still rational expressions, but notice that these are specifically quadratics. This is a quadratic, this is a quadratic, that's a quadratic. So what they do is they factor everything first. All right, so let's look at 5a. I have x squared minus 6x minus 16 divided by x squared minus 16x plus 64 times x minus 8 divided by x squared plus 5x plus 6. So it's really important, and you guys might see this on your ALEX assignment, so I want to make sure we're okay with this. So let me just go over to my notebook. All right, so it's the same problem that we just were doing. The only difference now, this one's a little bit harder because it's quadratics. So instead of just multiplying them together and simplifying from there, now we're going to go, we have quadratics that we have to deal with. Before you guys multiply them together, you want to definitely factor them first. That's really important, or you're going to get confused. It's going to be a waste of time, really. So we want to factor. The nice thing about these is notice that every single one of these quadratics has an a coefficient, meaning the number out in front of x squared is 1. So we can take a shortcut for every single one of these. Okay, the first one. What two numbers multiply to negative 16 and add to negative 6? Well, it's negative 8 and 2. So our factor would be x minus 8, x plus 2. Now look at the denominator. What two numbers multiply to 64 and add to negative 16? That would be x minus 8 and x minus 8, because negative 8 times negative 8 is positive 64. Negative 8 plus negative 8 is negative 16. The second fraction stays, right? There's nothing to factor here. Just it's a linear function, just x minus 8. Denominator, what multiplies to 6 and adds to 5? That would be x plus positive 3 and x plus positive 2. Okay, so notice before, this is the big difference that I want to talk about is if you have a quadratics, you got to factor them. Don't multiply them out, just factor them. Because if you were multiplying them out, you'd have to simplify anyways and factor back, and it would be redundant. So just always remember to factor first. And now I can start canceling some things out. Okay? So let's see. I have an x minus 8 in the numerator. I have an x minus 8 in the denominator. I have an x minus 8 in the numerator. I have an x minus 8 in the denominator. I have an x plus 2 in the numerator. And I have an x plus 2 in the denominator. So I'm left with, everything got canceled into 1 except for x plus 3. So I'm left with 1 over x plus 3. How satisfying is that? Being able to just like cross stuff out and simplify it down. Whoa, ow. So I went from the original multiplication of rational expressions, and I got all the way down to 1 over x plus 3. It's pretty cool, pretty satisfying. So that's nothing, that's just like we've been doing. Difference is quadratics, factoring. And I wanted you guys to get a lot of practice with factoring. It's an important skill, so yeah, just wanted to show you that. Okay, and then there's one more thing I want to talk about before this lecture is done. And again, nothing new. This isn't going to be anything crazy. I'm not teaching anything new. It's just a different way to look at some of these problems. Okay, and the only difference is just how it's written. And we call these complex fractions. Complex fractions are just fractions within fractions. So I really don't know if you guys have seen anything like this before. So I figured I would address it just in case. I kind of assumed you had, but maybe not. So we have something like this. A plus b divided by 4 divided by a squared plus b squared plus 4. So regardless of whether or not you've seen this before, or this kind of setup, a complex fraction, regardless of what you've seen that before, you can still understand what this is saying. This is saying we have this fraction, a plus b divided by 4. And we're taking that fraction, we're dividing that whole thing by another fraction, a squared plus b squared over 4. That's what this is complex fraction saying. This is really all I wanted to get across. Okay? This ugly looking thing that no one wants to look at just changes into the numerator divided by the denominator. Which means, right, we never divide by fractions. We multiply by their reciprocals. So this complex fraction in blue ends up equaling a multiplication of rational expressions. All right, and then you can see we have a 4 on the numerator and denominator. So to simplify it, I'm left with a plus b over a squared plus b squared. That would be my simplified answer for that. All right, so you guys can see with these problems, there's always a pattern. We're always going to make it so it's a multiplication problem. Always turn into a multiplication problem of rational expressions. If it's a quadratic, you factor. If it's not a quadratic, you just cancel like terms. So you should always be seeing some sort of cancellations. Or you should have a red flag to go off saying, I don't think so. Someone's not right here. Okay, let me stop there, guys. Any questions? Looks like a couple people are leaving, so I'm assuming that we're good. Jaden, thank you for answering. No. That's all I got for you guys today. So just understand Alex is open. It's due Friday, but try to get that done. Try to look at it. So if you guys have questions throughout the week, you can ask me. You're not waiting till last second. It's fair. It's not super long, but it's long. It's a longer assignment than I've given during this quarantine. So don't procrastinate. Don't put it off. I'm officially putting in grades tomorrow. So if I don't hear from you, your grade's what it is for the third quarter. So just keep that in mind. But I hope you guys have a great rest of your day. I'll be back on Wednesday. I will also be back on today for office hour. So from 1 to 2, you guys will see me if you want. Stop in, ask any questions. If not, though, have a great rest of your day, and I'll see you Wednesday.